Okay, we're studying the Earth's and Sun relationships. Climate and weather are the first thing that we'll be taking a look at. So really, what is weather? Let's see if I can get these pictures to... Okay, no it's not. All right. So look, we're studying the climate and the weather. The first thing is the weather. What exactly is the weather? Well, the weather are all these things that the pictures are. I kind of wanted them to pop up one at a time instead of showing all at one time, but that is okay. Let's do what it do. Weather. What the weather is, it includes things like your temperature, cloudiness, sunshine, precipitation, humidity, snow. The thing is that the weather, when you're dealing with the weather, it includes these things for a very short period of time, 24 hours, 48 hours or less, something like that. That is what we're thinking about when we think of the weather. So we're thinking about conditions for a short period of time. So, now that brings us to, all right. Now climate. Climate is the same. Climate contains the same conditions as the weather: temperature, sunshine, cloudiness, precipitation, humidity, wind speed. The exact same things as the weather, except for one big distinction. Climate takes place over a long period of time. Okay, weather is a short period of time. Climate is over a long period of time. Now, the most important thing that we need to realize about the climate, or what affects the climate, is represented by this graph, and that is the Earth's position in relation to the sun. And what this picture or this graphic shows you is that where the Earth is in rotation to the sun for each of the seasons. So this is where, for example, this is where the Earth is when we rotate around the sun for the winter, spring, summer, and fall. And of course, what this picture is not showing, not only is the Earth rotating around the Earth, but it is also spinning on its imaginary axis. So if you can imagine the Earth spinning, or not only rotating around the sun, but spinning on its axis, that would give us a general idea of what we're working with. Now, when we're talking about the variations in sunlight, that should be the next topic that we're up to. The thing that you want to realize is this: because the Earth is on an axis, and what that means is that it's tilted. So because the Earth is tilted, not all of the Earth's, taking a look at this picture, you'll see that not all of the sunlight reaches all of the Earth at the same time. So just kind of taking a look at this picture, we'll see that the sun's light and heat do not reach all of the Earth at the same time, nor with the same intensity. And this graphic is also another example of the Earth lying on its imaginary axis, or spinning on its imaginary axis. The Earth actually faces the sun at an angle, so you can see that the sun rays are not hitting all the points of the Earth at the same time. It's not hitting all the points of the Earth at the same time or with the same intensity, because one, the Earth is round, and two, it is not facing the sun straight up. It is facing the sun tilted. It's tilted when it faces the sun. So the variations that are in sunlight, once again, the variations in sunlight are caused by the Earth's tilt. And this picture, once again, just gives you a better idea of the sun's tilt. If the sun was, here you go, yes, okay, so this would be the axis. This is how the Earth would go if it was sitting straight up on its axis. But this is actually, this one is actually where my cursor is now, is the actual axis, more actually of how the Earth would be going towards the sun. Now the Earth rotates on its axis, which is an imaginary line. It runs from the North Pole to the South Pole and through the planet's center. Now, I know a lot of this stuff is just a review from elementary school for you guys, but let's kind of go over it. Because of the tilt on the Earth's axis, not all of the places on the planet receive the same amount of direct sunlight at the same time. We've already kind of gone over that, but we also want to make sure that you understand that the angle of the tilt not only affects the amount of sunlight that we receive, but it also reflects the temperature of the temperature of the Earth. So the variations in sunlight are caused by Earth's rotation, not only its axis, not only where we're tilted, but the fact that we're spinning around the Earth. So whether a particular part of the planet receives sunlight depends on the side of it that is facing the Earth, and that just makes sense. As we're spinning around, and then we're spinning around like a top as we spin around the Earth. So as we spin around like a top, the part of the Earth that is part of us that is facing the sun is at daytime, and then when we spin away from the sun, we're at night. So whether a particular part of the planet receives light depends on what part of that top, if you imagine us as being a top, which part of the top is spinning towards the sun. If we're facing the sun, we receive a lot of light. If we face away from the sun, we do not receive as much light. The Earth spins or rotates on its axis every 24 hours, once every 24 hours. Now, when we also discuss some of the different variations of sunlight, they're caused by, of course, the Earth's rotation. We've covered that. But we did not cover the way that the Earth rotates. The Earth spins from east to west. It turns on one hemisphere. There's that word again, hemisphere. Going back to the first week, it turns on the first hemisphere and then the other towards the sun, alternating between the light of darkness and the light of day. What exactly is this saying? That's a lot of words I just gave you. Well, this is what it's saying. When the Earth spins around the sun, there'll be one hemisphere, because only half the Earth can face the sun at one point in time. One hemisphere will actually receive light. During that time, that hemisphere is daytime. And then when that hemisphere spins away from the Earth, it'll be in darkness. And the hemisphere that was not facing the sunlight, is at night. It's now in day. So daytime in the eastern hemisphere is nighttime in the western hemisphere. So because of this, daytime in the eastern hemisphere is nighttime in the western hemisphere. The times in the different hemispheres are switched, all right? And so nighttime in the eastern hemisphere is daytime in the western hemisphere. And this kind of shows you the graphic. This graphic kind of illustrates it a little bit. In the western hemisphere, we have our North Pole and South Pole. If we take a look at it, this is where it's daytime in the western hemisphere. We're in the western hemisphere. These are the countries that experience daytime at the same time. In the eastern hemisphere, these are the continents or countries or the parts of the world that experience daytime at the same time. So we experience in the United States, we experience daytime similarly, same time as people in South America and Canada. And in the eastern hemisphere, Africa, Europe, Australia, they all experience daytime at the same time. The Earth's revolution. So the Earth's revolution is actually what we call when the Earth spins. Now, like I mentioned earlier, while the Earth is spinning or rotating on its axis, it is also traveling in orbit around the sun. It takes the Earth about 365 days, a little bit more than 1 year, to complete one revolution or trip around the sun. This graphic kind of gives us a better idea of actually what is occurring. If you can follow the arrows, it shows these arrows around the Earth shows the Earth spinning on its axis, and then also while simultaneously traveling around the sun. And that brings us to the seasons. Now, taking a look at this graphic, the seasons of Earth, the seasons are caused by where the Earth actually falls on the sunlight. So which part of the Earth is facing the sun while it's spinning on its axis, and its rotation also determines which seasons that it is. So taking a look at it, we'll see here, if just looking at us with the United States, when the Earth is in this part of its rotation, it's in spring, or this part of its orbit around us. When we have moved to this part of our orbit around the sun, we're in the spring. For those 3 months we're in the spring, it feels like probably for 2 weeks here in Louisiana that we only have spring. But then when we're in the summertime, which feels like the majority of our time in Louisiana, this is actually where the Earth is in its orbit. In the autumn, this is our location. In the winter. So just kind of quickly recapping, the Earth's revolution and tilt, these cause the different changes of the seasons. So the angle and amount of sunlight that reach the Earth at different locations on the planet, those things are what cause the seasons. So once again, the Earth's rotation and tilt cause changes in the angle and amount of sunlight that reach the Earth at different locations on the planet. These changes follow a regular pattern known as the seasons. And once again, this in this picture or this graphic, this illustration represents where the Earth is in its rotation to the sun in the spring, where the Earth is in its rotation to the sun in the summer, where we are in the fall and the winter. When we're working with dealing with the Earth's orbit around the sun, there are two big things that we, or two big words, or two big concepts that I want to make sure that we're solid on. One is the equinox, and the equinox occurs here and here. So almost when at the it occurs at pretty much the equinox occurs when the Earth's rotation is here, in the orbit on the sun here, and the Earth's rotation in the sun here. So either of the two times of the year, and what the equinox is any of the two times of the year when both parts of, when the sun rays fall directly on the equator, directly on the equator. And what that means is that is the first time, or that is the only time during the year when both daytime and nighttime have an equal amount of sunlight. So in September, during the September equinox, in March, what we call during the March equinox, those are the only times in the year where the sun falls directly on the equator. And the benefit to us is that, or how that affects us, is that this is when the daytime and the night both have the same amount of daylight and nighttime. The solstice is the next concept I want to make sure that we're good on. And the solstice occurs when the Earth is in its orbit here and here. So when we're in our orbit relation to the sun here and here in December and June. And what occurs in the solstice, that's just any two times of the year when we're the furthest away from the equator. So the solstice is different than the equinox. It's pretty much the opposite of the equinox. So the solstice is the two times of the year when the sun is the greatest distance from the equator. And so when it's actually in our solstice, there are two spots that it directly strikes. One is the Tropic of Cancer, and the other one is the Tropic of Cancer at 23.5 north latitude. And the Tropic of Cancer is the northernmost point on the Earth that receives direct sunlight. And with this graphic, before I'll go into to the definitions and everything, I'll show you just quickly walk you through this illustration. This is if we were looking at the Earth. This is taking the Earth apart for the summer. This is pretending this is the Earth in its orbit. Because we're here, and this is where the space is, you can see that we're leaning towards the sun. The northern hemisphere is actually on its axis, on its tilt, is closer to the sun. So during this time, during the summer months, the northern hemisphere receives more light. And that makes sense if we live in the northern hemisphere. So during the summer months, our summer months, or the daytime is longer during our summer than it is during our winter. And also, conversely, during the winter time, you can take a look at where we are. This represents this illustration represents the Earth and us in the United States. During the winter, we're tilted away. By this time, we've moved into our rotation to where we've tilted away from the sun. And so during this time of the year, more sunlight hits the southern hemisphere and less is on the northern hemisphere. So this is during our winter when our days are shorter. This explains why seasons are reversed in the northern and southern hemispheres. Also, the amount of sunlight that both the North and the South Pole receive varies dramatically. So for the 6 months, or for approximately 6 months that the North Pole is closer to the sun, it receives about 6 months of direct sunlight all year long. It's no daytime. And down here, for about approximately the 6 months that the southern hemisphere is closer, the South Pole is closest to the sun, it has daylight directly for 6 months. Now, what occurs during the time when they're the furthest away? About nighttime for 6 months. So for 6 months out of the year, one pole is tilted toward the sun and receives continuous sunlight, while the other pole is tilted from the sun and receives little to no sunlight. And what we call this phenomenon is called midnight sun. And what midnight sun means that in the North Pole, here, the North Pole receives continuous sunlight from March 20th to September 23rd. And the South Pole receives continuous sunlight from September 23rd to March 20th. The end. See you in class.